Hey guys, Ake with the ChainStack Developer Experience team here. Today we're looking into how to do token swaps on Raydium exchange on Solana. And we're going to do this programmatically. But first, what is Raydium exchange? Raydium is one of the top decentralized exchanges and automated market makers on Solana. One of Raydium's features is its ability to tap into the order book liquidity from Serum, which is another Solana-based decentralized exchange. This makes Raydium sort of a hybrid model that combines automated market maker liquidity with the central limit order book. As of recording this video in July 2024, Raydium's TVL is about 1.3 billion. And the 24-hour volume of Raydium is equally impressive at 1.3 billion as well. It's just a 24-hour number. Obviously, these are very lucrative numbers that you may want to tap into. So now let's do a quick overview of why we are doing this. Why do you want to do swaps programmatically? There are a lot of reasons, and the chances are, if you're watching this video, you already have your own ideas. But for a couple of examples, say you have a system that spots new token listings on Raydium, and you want to be fast in being able to get those. Or you have a system that's monitoring the market and you want to be able to do the swaps based on the specific market conditions, like token price going down or something else. And you want this system to be autonomous because sitting here and watching the market 24/7 is not productive. Being able to execute the token swaps programmatically is a necessary component in these or similar systems. So how does it work? Before we dive into the code or before we do the demo of the project, let's do a quick overview how the whole thing works. We have a Raydium exchange that we operate with. The Raydium exchange has the information on all the token liquidity pools and all the tokens listed on it. We have this information and we want to be able to execute the swaps based on this information. So all the liquidity pool data is in the file called main.json on the Raydium exchange. It has all the liquidity IDs, it has everything you need to correctly perform a swap. The problem with this file is it's a huge file. It's a 500 megabytes file. So to download it and then load it into the project takes a reasonably long time. It's not effective, but you do need the data in the file. So that's why we need some sort of preparation. We need to download the main.json file first to our machine. Then we provide the addresses of the tokens that we're going to base the exchange on in the swap config.ts file. We are going to touch later on this file. And having provided the token addresses in the swap config.ts file and having the huge main.json file, we now run the trimming script called trim mainnet.ts. The script takes the token addresses from the swap config.ts file, finds the relevant liquidity pool data in main.json, and produces a trimmed version that's hundreds of times smaller and thus can load faster in the project. Raydium SDK then uses the trimmed main.json file to do the rest. The project is using the Raydium library. It sends a query to the chain through the ChainStack Solana node. The query on the latest state on the liquidity pool for our two tokens, which is basically the exchange rate. Once the project retrieves the data from the Raydium exchange through the ChainStack Solana node, it again uses the Raydium library and the Solana Web3 library to construct and fully prepare a signed swap transaction. The transaction is then sent through the ChainStack Solana node, gets picked up by a validator, gets confirmed in a block, and then you have your swap performed. So once again, the overview is get the metadata file of the Raydium exchange, which is a huge JSON file. Trim this file to only have the liquidity pool information data for the specific token pair that you're going to perform the swap on. Then use this data to query the latest exchange rate on chain through a ChainStack Solana node from the Raydium exchange. Then use this data to prepare the transaction and then send the swap transaction on chain and get it confirmed and get it done, and that's about it. Okay, Now let's do a quick run through the project structure. But before we do this, a quick shout out to the developer that goes by the nickname Precious Void, who created the original base code that our project uses. The link to the original project is in the description of this video, so go ahead and give the original one a star. But on with our project. It's all TypeScript. It uses the Raydium SDK and the Solana Web3 JS library. The main file for you to look in is swap config.ts file. It's all self-explanatory here. On execute swap, if you set it to false, it's going to emulate the transaction, but it's not going to send it on chain. If you set it to true, it's going to do the actual transaction. The use version transaction set is set to true and makes it use the latest Solana transaction type instead of the legacy transaction types. Token A amount is obviously how much of a token A you want to swap for token B. Token A address is the address of the token going in. Token B address is the address of the token going out. And for the liquidity file, you have the one that we already prepared, which is the trimmed version file. And for max retries is how many times you want to retry a transaction if it fails for whatever reason. And in the Raydium swap.ts file, you can also set the slippage percentage. By default, it's set to 5. And the trim mainnet.ts file is our trimming script. So, all right, that's about it. Now we can do the project demo. Let's go. Okay, so this is our repository here. Let's clone the repository. Okay, now let's do yarn to install all the dependencies. And now let's create the env file, right, which is going to have the chain stack RPC endpoint and the private key that we're going to use to send the transaction. And obviously your address needs to be funded. Okay. Now we need to, as you remember guys, now we need to get this huge main.json file. Let's actually just copy the command. Okay, let's do get. Let's actually just copy the command and get the download the file. Okay, in the project root. Okay, 500 megabytes. That's a lot of liquidity pools and a lot of tokens in there. Right. And as we said, we obviously do not want to load the full file. It's going to take minutes, literally minutes, whereas it could be taking seconds. So we don't want to be using the full file just to the one liquidity pair. Now that we have the full main.json file, we can trim the file for the liquidity pair that we really want to do. So let's actually, instead of doing the default one, let's swap the values. Raydium. Let's go to the Raydium exchange and look for the liquidity pairs that are there. For example, recently we were looking. I was looking into a case where someone wanted to do a swap of render token for Sol, so we can do that. We can find the render token that you can see here address. So let's use this address in our swap config file. So the token going in is going to be Solana. And the token out, token B address is going to be the address of the render, which I believe is the DPN project. And this is the address, the token that we want to get as a result. Okay, so now we have the token A address and token B address in our swap config.ts file. So we can now run the trimming operation. Oh, I need to install TS node. Okay, now let's run the trimming operation. Okay, let's check the trimmed file. As you can see here, we have the liquidity pair, liquidity pool with this idea for Solana to the render tokens. And so now that we have the trimmed file, we have the environment variable set up, we have the chain stack node in there, we can now run the actual swap and get our render tokens in exchange for Solana at the exchange rate that's the latest right now on the chain. Right, I need in the config file, we did an emulation, right? In the config file, I need to actually set the execute swap to true to actually actually execute the swap instead of just emulating it, right? Okay, let's run the swap. Okay, and here we have it. You can see the symbol and the name unknown here because we're not getting those from the chain. We're not using the metadata file for those. We can programmatically set it in the code, but there is no, if we really want so, but I don't think there is a real need for that. Okay, and now let's check our swap. Okay, as you can see, we actually got our rendered tokens for our Solana swap, for our Solana tokens. And there you have it. There you have it, guys. We did the swap programmatically. We used the Raydium exchange, we used the Chainstack endpoints, and sign up with Chainstack, the #1 infrastructure provider. Cheers.